All right, chemistry, welcome to this chapter 15 practice session. We've got a couple choice questions, some short answer questions, and some longer answer questions for you. Remember, this is not an assignment. This is just an opportunity for you to practice what we've gone over in this chapter so far. So press pause whenever you feel like it. Give yourself a chance to think. Give yourself a chance to construct your response. But here we go. Which of the following is not a characteristic of an acid? B. An acid has a bitter taste. No, it does not. Remember, bases have bitter tastes. Our word acid actually comes from ancient language for sour taste. It actually means sour. Like when someone says like this is acidic, they're actually saying this is sour. When an acid reacts with an active metal, remember active, highly active, hydrogen gas is produced, right? And not all acids, just some acids with highly active metals, right at the top of the activity series. Hydrogen gas will be produced. Which of the following is a Brønsted-Lowry base? Remember, we have three definitions of what it means to be a base. Which one is the Brønsted-Lowry definition? It's a proton acceptor. It is taking in the proton that is being donated by the Brønsted-Lowry acid. Which acid is the most commonly produced industrial chemical out of these? Which is the number one? Sulfuric acid. Sulfuric acid is actually in pretty high demand. It's the number one acid that people ask for different reasons. So it's the most heavily produced. Which of the following is a conjugate pair? Which one's the acid, which one's its conjugate? Which one's the base, which one's its conjugate? And yes, please remember these weird G's with the hats. These are minus signs, so please don't let that throw it off. I have no idea why this one works. Oh my gosh, I just noticed that. Why? Why you do this? Oh, why you do this? Anywho, which one of the following is a conjugate pair? It is C. HCl is the acid. HCl is the acid. And so the conjugate base is what's left over after the acid has donated its proton. So what is HCl going to be after it's donated its proton? It's going to be Cl minus. So that's a conjugate pair. Acid with a conjugate base. What is the formula for acetic acid? There's this big, long, annoying one, right? And you can actually see this written several different ways. These right here are not the ionizable hydrogens, by the way. This is. It's only got one ionizable hydrogen, and it doesn't even ionize all the time. That's why it is a weak base. Which of the following species is a conjugate acid of another species in this same list? So which one is a conjugate acid? Not only which one is a conjugate acid, which one is a conjugate acid of something else in this same list? So this is the conjugate acid. Conjugate acid. So there must be a strong base that is producing this, a strong base. And so you're going to get right here. This is a strong base. This is going to accept hydrogens like no other. How do I know? That is a large magnitude charge. Number 8. Identify the salt that forms when a solution of H₂SO4 is titrated with a solution of CaOH2, calcium hydroxide. So what salt will form? Is calcium sulfate, right? So we're going to have this acid get rid of these hydrogens, right? These hydrogens are gone, so we'll have sulfate left over. This is going to be the base, so after these hydroxides leave, what's left over? The calcium. Calcium sulfate. Calcium sulfate. Which of the following statements is true for the reaction below? And please remember, these are all supposed to be, these G's are supposed to be minus signs. So this is 2 minus. This is just 1 minus, 1 minus. Which of the following statements is true for the reaction below? The fluoride, why does that work? Oh, that's annoying. Fluoride is the conjugate base, right? I'm asking which one of these statements is true. Fluoride is the conjugate base of hydrofluoric acid, right? The conjugate base of an acid is what's left over after the acid actually donates its hydrogen. So after this this acid donates its hydrogen, what's left over? The F minus. So this is a conjugate base. So here's a short answer. Feel free to pause so that you can generate your answer. How does a strong acid differ from a weak acid? Give one example of each. A strong acid will completely ionize. All of the potential, a hydrogen will most certainly, 100% drop off into solution. A strong acid is 100% ionized. A weak acid is something less than 100%, something less than completely. And there's a big range in there, don't get me wrong, but anything that's not completely ionized is considered a weak acid. There's actually a small number of strong acids, and it's actually easier to memorize those. Memorize what are strong acids. Anything else is a weak acid. So possible strong acids would be hydrochloric acid, hydroiodic acid, hydrobromic acid, nitric acid, sulfuric acid, perchloric acid, and chloric acid. With very, very few exceptions, and there's some argument, right? There's some acids are actually getting closer to that 100%, but not quite. Like hydrofluoric acid, right? But with very, very few exceptions, anything else would be considered a weak acid. There are I don't want to say fake acids, but ones that have negative pH values that have to be made very, very carefully because they're super intense. We're not going to talk about those super acids. We're talking about regular acids. Identify the conjugate acid-base pairs in the following reactions, right? So every acid-base reaction is going to have 2 pairs. So you're going to need to show me 2 pairs. All right, first off, here is your acid. This is chlorous acid, right, with 2 oxygens. This is chlorous acid. And so after this 1 hydrogen leaves, that's going to be the conjugate base. So this is going to be the conjugate base. Please remember that these G's are supposed to be -1s. So chlorous acid, after this hydrogen leaves, because that's what it's going to do, it's going to donate this hydrogen. What's left over is considered the conjugate base. So here's your first acid, first conjugate base. What else do I got? Well, if this is the acid, that means that this ammonia is the base, right? It's going to accept the proton. It's going to accept it from the acid. Well, after this base accepts the proton, this is considered the conjugate acid. So, base, conjugate acid. Phosphoric acid, H₃PO4, has 3 hydrogen atoms and is classified as a triprotic acid, right? Because these 3 could potentially ionize off. 3 ionization steps. Acetic acid has 4 hydrogen atoms and is classified as a monoprotic acid. Explain the difference and justify your explanation by drawing Lewis structures of both acids. Ooh, it's rough. Each of the hydrogen atoms in phosphoric acid is attached to the oxygen atom and can ionize, right? They can ionize. They have the potential to ionize. Only one of the hydrogen atoms in the acetic acid is attached to an oxygen. The other hydrogens are attached to carbon and therefore don't ionize, right? In acetic acid, these 3 hydrogens are attached to a carbon, and so they are not going to ionize. The only hydrogen that's going to ionize is going to be the one that's bonded to an oxygen, and there's only one of them. So since there's only one oxygen that has the potential to ionize, acetic acid is considered a monoprotic acid. So let's take a look at what that would look like, right? Drawing the Lewis structure. So here's our acetic acid. Here's my two carbons, right? Here's my, my methyl group right here. We have the three hydrogens over here that are bonded to a carbon, right? These are not the ones that can ionize because these are nice and stable, right? Nice and stable. Got a double bond with the oxygen. This carbon's bonded to an oxygen. This hydrogen is bonded to an oxygen. This is the one that can ionize. But check this out. Boom, 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 all bonded to oxygens. Therefore, all three of those can ionize. Let's finish up with one more. Write the full equation, ionic equation, and net ionic equation for the neutralization reaction between ammonia and sulfuric acid, and identify the spectator ion. Might want to press pause on this one. Have at it. Alright guys, that's going to be the end of this practice session. Go ahead and press pause so you can take a look at these responses and check how you compared. Please remember these G's with the little hats are really supposed to be minus signs. Again, apologies for that.